How is everyone doing? Good? One person excited, that's awesome. Thank you, Martin. Great. So, did you know that on average, we're tapping our phones, we're clicking, and we're pressing our keyboards around 10,000 times a day? Think about that. 10,000 times. That's insane. That's 3.5 million voluntary hand movements a year. Room went quiet. Do you believe it? Who's a skeptic about this fact? Please raise your hand. 30% of you. The surprising thing is that this is on average, like the average person that uses technology. For you guys, people who code, it's way more. But there's a particular gesture that you're very familiar with, which is scrolling, that happens with these different types of gestures, whether you're scrolling on your phone or your device with touch, whether you're clicking and dragging your scroll bar, or whether you're scrolling with your keyboard. And for me, this particular gesture, scroll, is fascinating. It's fascinating because we are doing that so much, but we have no idea really how much we're doing that. This is one of the things that we're spending a lot of our time doing on a day-to-day. So I went and Googled and found something on Reddit of like, how much are we really scrolling here? Someone already had asked this question: how many miles or kilometers does the average user scroll on their phone screen? And some clever person came up with this formula of assuming around 90 minutes a day, how far are we scrolling in a span of around 2 years? Are you ready for it? It's around 236 kilometers every 2 years, which is a lot. So every time I hear that, I just imagine like everyone just like scrolling. And that sheds some light into the 3.5 million hand movements we're putting in order to interact with technology. My name is Castillo, and I love building tools to empower other people. For the past few years, I've been working specifically in the neurotechnology world because I find the brain to be fascinating. I've learned so much. I always felt that the brain was like the most advanced computer. And there are so many interesting facts about the brain. And we could be leveraging our brain for far more than we're doing today. We're using our traditional interfaces, our mice, our keyboards. And I really think about the next generation of users. How are people that are going to start learning how to use computers, start using these devices, they're going to adapt like we have to these interfaces so we can communicate some intent into a computer? Well, my company, Neurosity, we're building hardware and software so we can use our thoughts to interact with technology. And this is super interesting because if we could only communicate more seamlessly with technology, what would the world look like? On the hardware side, we have been working nonstop on hardware that we started building from scratch. We started thinking, why this technology, right, EEG or electroencephalogram, it has existed for almost 100 years. Why are people not using this technology on their everyday lives? So we took a step back. We saw all of the other existing technologies and what is holding them from really being useful or from working. There are many challenges, of course, but by really starting to think about people and their needs and the value that this technology could produce to to people in their everydays, we started working, and I'm really excited to show you our device. We call this Notion. I actually have it right here with me. And Notion is many things. Well, you can call it a brain-computer interface, you can call it a neural device, you can call it a wearable computer, but ultimately what it does is that it sits at the top of your head, and it reads the electrical impulses produced by our neurons. We have billions of neurons, and they produce electricity. And leveraging this data with today's technology, mostly focused on using artificial intelligence and machine learning, could definitely bring this technology to a point where we can start using them. But here's what I really love. I've been doing JavaScript for probably 15 years now, and the web, the most open and amazing platform ever, should be first-class citizen when it comes to working with such a technology like this one. So, of course, there's a JavaScript API that we can use that does machine learning on the device, and that is connected to the cloud. And ultimately, it's not the same as when you're working with your traditional input devices, of course. When you enter some text on the web, for example, you're getting several events a second maybe, right? When we are working with brainwaves, it's very different because those inputs are effectively the microvolt values that we're getting from our brains, from 8 different parts of our brains. It looks something like this when you see the data in its raw format. And honestly, like, what does this tell you? It doesn't tell you much, right? It just tells you that there are some oscillations, and these data changes in the microvolt values over time. And we're getting 2,000 numbers a second. So when we're working with brainwaves, definitely there's a lot of things that we need to do in order to keep crunching these numbers into something meaningful. So how do we get from such a chaotic amount of data, and how do we turn that into something that we can actually use that is intentful? Machine learning, of course. And by being able to run machine learning on the device, we are offloading a lot of work that we would have done with our traditional computers, which makes this device autonomous, and which ultimately give us something really of real value. So I want to introduce the first concept, is motor imagery. Does that mean anything to anyone here? Please raise your hands. Oh, that's amazing. There's one person here. So motor imagery is very exciting because it turns out that all the billions of neurons in our brains, right? There's a particular region that is called the motor cortex. And the motor cortex is the part of the brain that is responsible for planning and executing voluntary movements. This is where everything starts when you're using your hands and your bodies. And a big part of that is dedicated only to our hands. We're really good with our hands. And ultimately, we use them for everything, right? So when thinking about interacting with the web and clicking and using our keyboards and all that, that mostly comes from there. But without actually moving your arm, but thinking about moving your arm, the motor cortex, that region of the brain, would still produce enough electrical activity that can be detected. And if that can be detected, and we have hardware that is capable of running this machine learning algorithms, we could try to, you guessed it, take that input of random data and turn that into something intentful. So I want to give you a quick snapshot of what that looks like. The motor cortex produces electrical activity that is related to our movements, planned. If you imagine a gesture, right, such as moving your left arm, Using that imagined movement can be detected with some algorithms in machine learning, mostly spatial algorithms. And this is when we introduce the Notion API. We're doing all that work on the device so you don't have to use those brainwaves, but you can start using these imagined movements. I'm going to give you a quick preview of what that API looks like. So the Notion API, I love creating a variable that is called mine because ultimately that's exactly what we're doing, just getting to the mind and being able to access a specific parts of it. In this case, motor imagery specifically. So by instantiating a new Notion, we can add the device key and API keys, of course, so we can point to the right device. Today we'll be using this one. And then we can, at the low level, we can start requesting or subscribing to predictions. If you're familiar with technologies like RxJS, we're using observables in order to access this data. So by passing different labels, for example, a left or a right imagined movement, we're able to subscribe to these events taken from motor imagery. In this case, this would output something like this, which would have the label value and then a probability going from 0 to a 1. And these probabilities will fluctuate, right? And of course, they get lower as you are not thinking about a specific imagined movement, and they would get higher when you're thinking about these imagined movements. But predictions are pretty cool. But if what we ultimately want is that decisive moment of what intent really is, this is when we introduce the Kinesis API. And Kinesis uses predictions under the hood, and what it does is that it takes a label. In this example, I'm using like a left-hand pinch. We love using the left-hand pinch, imagine movement, because it's a very strong signal since we're using our hands. And everyone knows how to do a left-hand pinch. Can you do a left-hand pinch for me? That's so cute. All right, so ultimately we get not probability, but actual events are fired whenever left-hand pinch imagine movement surpasses a threshold. And what that means is that we don't get a probability, but we get more of a confidence. So we get a value of a confidence from 0 to 1, but it only fires after you have been imagined that label, left-hand pinch, for a specific, it would probably be around 1/4 of a second to 1/2 a second, and that's when the event fires. So you can quickly start comparing this to when you intend to do a click with your actual hand, you would go, grab the mouse, right, and you would click. There's a very precise, intentful type of event. In our case, we use Kinesis, and we would imagine that movement, and it will fire an event as well. So the first thing that I want to do is that I want to, well, first, I should turn this on. There you go. And I would like to show you a little bit of what these probabilities look like. So I have a friend here that has agreed, I don't know why, but has agreed to come to stage here. Lucas, please come to stage. And we're going to be using, yes, please give it up for Lucas. Yeah. There's an actual spot here for you. Yeah. So Lucas, thank you. Lucas has agreed to just be the volunteer for today, and he's going to be wearing the headset. I gave him a little preview earlier today of what that does. We didn't do like a full training session, right? So usually you would like go to an app and do a training. So the machine learning algorithm has a reference of what you consider to be a left-hand pinch or an imagined movement. And we do that because every brain is different, right? Turned out, even before the training, we previously trained data from other brains, right? Brains from New York, most likely. That's where I come from. Lucas was able to start getting predictions that were like slightly past a low threshold of like 0.5, so like half, past half the hold unit. All right, so Lucas, you know what to do. You're just going to put it on. I'm sorry it's going to mess your hair a little bit, maybe. I know you spent a few hours working it. Oh, yeah, that looks great. So if you don't mind, just like turn it around so they can see the device looks like. There you go. Yeah. So you know the drill. That left-hand pinch, you're going to imagine it whenever you want to see it. The probability is like increase. I have a small, very bare bones app that's going to visualize this with a progress bar. Are you ready? Yeah? All right. So let's see. Let me see. All right, so the device is going to come online a bit. So we're about to start. I guess you can see the progress bar, but this is just a very simple progress bar that we're going to start seeing the probabilities. So remember, in order for you to like think of the imagine movement, it's very simple. You think of doing a left-hand pinch. You don't do it, but you almost kind of go to do it and you stop yourself. And then we're going to see from 0 to 1, what are the odds that Lucas is thinking about an imagine movement, and therefore proving motor imagery as a BCI concept. Sounds good? All right, so let's see if this is on. There you go. Is on. There you go. All right. So the bar is yellow. The goal is for him to surpass a 0.5 and turn the bar to green, and that would be kind of like past the threshold. So you can start thinking of the left-hand pinch now. Don't make him laugh, please. There you go. Yeah. Yeah. So I'm really happy that you did that. There's no full training, so like this is using other people's data, and the whole goal is that Lucas does a full training so he knows specifically what his brain patterns look like in this example. Thank you so much. Stay right here, because next thing I actually want to do is not this. But yeah, so what I want you to do you mind just staying here and sitting next to me? I want to show you a little bit of code right here in this tool. Just to prove the concept of how this is visualized is that we're using React to visualize the probability in that progress bar. So I'm going to go really quickly into giving you a little bit of UI code there. We're going to be using hooks. Are you familiar with hooks here? They're awesome, right? Yeah, awesome. So we're going to be using the Notion API. And the most important part is just like have a very simple state that we're going to call probability. This is a very simple component that returns as an empty div. But we're going to use an effect. By using an effect, we would pretty much join the mount lifecycle, right? We can create a subscription, which uses the mind, remember, from the new Notion, does the predictions for the left-hand pinch, subscribe, and pretty much takes that value, updates the state, and returns the subscription, so when the component unmounts, it can clean that up. This is the fun part. We're using an HTML5 meter element, and we're passing the value to probability, and as you can see, in our example, we use the high value as a 0.50, so that's when it turns green. So all that functionality, all that behavior comes right off the box. And that's pretty much the whole app that you saw with an extra bit of CSS. Now, intent is a little bit more interesting, because intent is when it surpasses, those probabilities surpass the threshold for a specific amount of time is when we consider them intentful. But I have a more interesting demo to show you. And to be completely honest, full disclosure, a little bit nervous, never done this at this scale, because we have tried this using this device to do some interactions with our computers and our phones. But I've never done it where pretty much everyone here is going to be involved with, I heard there's a few hundred people here, so everyone here is going to see the intent on their phones or computers. Are you down for it? Yeah? Are you sure? I don't know. Do you think they're down for it? Yeah? All right, so we're going to be using the Kinesis API to do something that you might be familiar with. Do you remember when we were talking about those 3.5 million hand movements and how scrolling was like a big part of that? So we're going to do a thing to scroll. Thing to scroll for us is exactly what it sounds like. Lucas is going to think of that left-hand pinch, which is going to trigger an intentful event from the Notion Kinesis API, and we're going to scroll a web page. Actually, several hundred web page if you want to join with the experiment. What I want you to do is to go to thinktoscroll.com with me, and I'm going to show you a very simple app that has facts about the human brain, and Lucas is going to do his best to start scrolling. I'm not going to say to the very end because that's quite a bit of scrolling, and we know that it takes a little bit of brains, if you may, to get there. Not like like smart brains, but like just you have to really train for it. All right, so since we're there, I'm going to go here. I'm going to go to Think to Scroll, and you're going to start thinking of that left-hand pinch. The same progress bar is at the very top. So let's see. Are you guys loading? Yeah? So I'm going to close this one, and I'm going to come here. And let's see, just making sure I have enough juice. 33%, that's fine. And by the way, if anyone is trying to scroll the actual page, I disabled that, so it can only happen with Lucas' brain. All right? We do have the value here at the very top right corner, and I'm waiting for those events to come in here. So remember I told you I was nervous? It's because we haven't tried it with many people, and just to see how many people we actually have here. We have 200 people loading the website right now. Never have tried to scroll 200 devices, so let's see what happens. All right, you guys keep joining. Awesome. There's someone that is actually joining from very far, probably from the stream, right? Okay, fine. Yeah, yeah. And what I want you to do is just, I want you to pay close attention to your phone. And at some point, I might ask you to show me, because I would love for Lucas, there you go, to see his brain scrolling down all those devices. So bear with me. Oh my God. I'm going to get in big trouble here. I don't know why I decided to do this, but let's give it a try. Cool. So what do you do when something is not working? You just like open DevTools or something? Yeah, there's no errors. It works. So I'm going to do a hard refresh here. If it's working for someone, can you show me? Oh, that's a beautiful. You guys keep it right there. There's someone with a laptop like holding it. I just want to take a quick picture. All right, everyone, show me those devices. Okay. So everyone loaded the first page, so I'm going to go here. I know, it doesn't move yet. I know. That's exactly what I'm about to debug. And we have a quick way to find out if we're getting predictions or not. We're connected to the Neurosity Wi-Fi. We're not getting predictions just yet. What is not changing? The values. I know, yeah. Wait for it. You can see what's going on, huh? You know, I'm going to do the same thing I do with my computer. I'm going to restart it. All right. So you just stay there. I'm going to go restart it. And while this restarts, I'm going to show you a little of the magic behind the demo. Sounds good? All right. So we usually don't have to do this, but if we wanted to scroll down a web page, we would use a window.toScroll method, right? In this case, we use the object notation, we pass a value. In this case, the gesture is going to be like around 100 pixels or maybe more. And what I do is that I create a variable that I call the scroll step. The scroll step is exactly what it is. It takes a, well, when we're passing the top value, the current y-axis position plus the step, and it would basically scroll down. The behavior that we're passing is called smooth. We just create an animation for us, so we don't have to do the manual incremental value for it to scroll. I'm going to put a nice function here called scroll down. So far, so good. And after we do that, we're going to use the Kinesis left-hand pinch API. We're going to subscribe, and we're going to pass that function. Cool. One of the very interesting parts about working on this project is that, you know, as I work and as my partner AJ, as we work on this together, we do believe in this future where like we can do way more with our minds. But at the end of the day, while building this, we are using our hands and we're coding a lot and we're building hardware and we're building software. And we just simply wish this technology was like ready to, you know, to that point where we don't need to use these traditional interfaces anymore, and we could be the most productive that we could ever be. So definitely working on something like this, it's a little bit of like very hopeful because you know that at some point we're going to get it, right? And as we get closer to that. And on the other hand, then you have that little bit of feeling of frustration that it's not ready as fast as you wish. All right, so this device should come up online now. I'm going to give a try to the left-hand pinch here. If we get predictions, then get ready because we're going to jump right to the scroll demo. I wonder if we're getting the raw brainwaves right now, or if not. Amazing. All right. All right. That's fine. I'm fine. This is fine. Yeah, thank you. Thank you for the support. Wait for it. You know, if you ever wonder how you debug this in a live setting, I'm right about to show you. I'm going to SSH onto the device. Let's see, what the hell is happening? Yeah, we can see learn, it loaded the classifiers. We have our different containers here running. And then there you go. Wait for it. Oh, I know what's going on. This is good. This is good. Bear with me. We're going to scroll some devices today. I promise you. Unless this runs out of battery, it's 32%. To my benefit, never tried it in Russia before, okay? I tried in multiple cities in the US. This is a new experience for me. It's fine. Yeah. You'll see it. I'm in the right domain. Yeah. Okay. All good. Lucas, don't worry. Like, I hope you're not thinking of the left-hand pinch all this time, right? You're like, not yet. It's like, I'll tell you when to do it. Yeah? Okay. It's all right. So we're getting the raw brainwaves, but it's very laggy. I'm gonna blend that on the internet. Yes, I'm doing the speed test. I'm not gonna give up on you guys. I promise. This is pretty good. Cannot blame it on the. We're getting the raw brainwaves here. Wait, don't worry about it. It's fine. No predictions yet. Well, that would make sense. All right, Slaggy Buddy's there. All right, I'm gonna take your advice, man. I mean, you were the only one who gave me some advice. Can someone just close the thing2scroll.com for a second? And remember, I can see you. Like, I'm right here. Thank you to those 30 people. I see you with the phone right there. Yeah. You guys are awesome. All right, this is stopped. This is stopped. All right, I think I'm gonna do the local one and see what happens. Is it the one? Here you go. All right, someone try to go to /admin. That was just beautiful. Okay. All right. I have an idea. I'm just gonna show you the video we shot last week, doing the same thing. So this is kitchen. You guys ready? Yeah? Imagine this is Lucas. All right, so please give it up for the girl in the video. Thank you. Yeah. Yeah, so we were able to make it work earlier today. I guess it was a little bit ambitious to do the, couple hundred people right there, but I'm going to tell you a little bit more of what, our next plans are. Thank you. Give it up for Lucas as well. Yeah. Thank you. Yeah. So one of the parts that we really want to focus on is kinesis and working really hard to start getting better predictions. As of right now, as I mentioned, you have to do some training. So the application knows exactly, the application running on the device has a better idea of what your own specific brain patterns look like. And based on that, feed that to the machine learning algorithms that are detecting the motor imagery. And based on that, get higher predictions while training, and as well as maybe eventually we can start and have an enough big data set that we don't need to train each single time or for every single user, and we can start reusing this collective data set that works because it has so much data about the different brains. One thing that I'm very excited about as well is what we call the Awareness API. The Awareness API gives you access to more like the subconscious type of data. A good example is that by converting these brainwaves to the frequency domain, you can get very basic cognitive states. You can get to quantify relaxation and meditation, as well as drowsiness and when you're sleeping or when you're highly focused. So giving you access to these things are they're not necessarily intentful and you're trying to provoke some type of reaction, right, to the devices around you, has equal value. And I'm going to give you an example of something that could happen. If we would subscribe to the Awareness API and pass a label of like drowsiness, then we could filter the confidence level of that drowsiness level and past the threshold, we could be firing an event. So I can think of a real world use case where you're tapping into the drowsiness of a driver while driving their car, and if the person is falling asleep because it's past the threshold, then maybe the car can pull over. And I can also think about many other examples when this data is necessary and important. For people who play video games, for example, what if video games knew a little bit of your state, whether you are focused or whether you're paying attention or whether you're tired? How could the experience of, like the video game could change, be tailored to exactly how you're feeling? I imagine a world where, just like when we give permission to the browser to open the webcam or to do certain things that require special permissions, that we could give the video game temporary permission to access our awareness and have our mental state be basically shared with that game, and that game changing based on our needs. If we're kind of getting bored, maybe something could happen in that experience that would make you re-engage with that experience. So this is something that we're working on, and I'm really excited that providing this type of information will create new experiences. We're all about empowering the mind and neurosity. And the reason why we do this and everything that we do is so we can provide tools that can change your life and that can make you either more productive or happier or healthier. So creating this API to the brain in a way that we can better quantify ourselves could definitely start educating ourselves of the things that we quite didn't know. Imagine a world where you can get access to quantified emotions in real time, right? Maybe you have certain applications that give you trends on your emotions and how that changes you. And maybe you can recognize some patterns about what's happening to you at the emotion level. Because everything really starts right here in the brain. Our mental state, our emotions, the things that we intend to do. So empowering the mind is something that we take very seriously, and this is exactly why we have been working on this hardware and software stack. We are very close to launching a very limited run, and the idea behind it is that we get feedback from people like you, from the developer community. the reason why we started this as software engineers or as hardware engineers or developers is because we want, to be completely honest, what we really want is just superpowers. And I think doing things like this, that getting that intent, getting that awareness, and getting to quantify those emotions is exactly in my definition of what superpowers really are. So this limited run, we're going to launch before the end of the year. And the idea is that you can start using it, and you can start getting your intent, and you can start accessing this API. We have big plans. We believe in open sourcing, so we're going to be open sourcing our own API, our own Notion API. So if you're interested in that, definitely check it out. But this idea of a world where we know how computers have evolved over time, right? We came from the mainframe to the PC and the laptops, and you can see how computers keep getting smaller, and in some way also like closer to our bodies, right? When the computers are in your phone and put it close to you, and you have this like relationship with your phone, and if you don't have it with you, you kind of feel naked sometimes. So we do feel that when it comes to the future of computing, this is exactly how we're going to be interacting. As of right now, as you can see, the only part that we're working on is really like the reading part, right? We can only read this type of very specific thoughts. We're not writing. It's not like the Matrix, like I know Kung Fu. But I do imagine a world where we do have read and write access, and the pace in which we learn can drastically increase. If we think about that saying about if you want to master anything, you have to spend 10,000 hours. We really think about these things. And should it take 10,000 hours? Maybe for some things, but could we gain some skills in a different way? Could we improve our bandwidth as humans? So if you're interested, go check it out, reserve a unit, and we're very excited about working on something that definitely is going to empower minds. And thank you so much.
Thank you, Alex. Would you like to join me for a little conversation?
Yeah.
So that's exciting. It's fascinating technology. I'm very curious, though, and this is actually some of the things that came up in the conversation in the chat as well. Oh, I'm afraid of it now.
Just check it out.
It looks pretty cool. I do have a couple of questions.
Yep.
So one of them is, so that girl from the video. So it's one thing if you think about, okay, I want to scroll, and you have a device in front of you, and that's it. But what if you do many things at the same time? Is it really easy to spot like that intent that you were speaking about? Or do we multitask in the end, or do we not?
It depends what you consider multitasking. If you think about in the morning or any time during the day when we have a lot of repetitive tasks, do you really have to think how to move your hand in order to brush your teeth, right? Mm-hmm. It depends what you define as multitasking. I think by some definitions, I think we do. At the very scientific level, I wouldn't know. But yes, with this, for example, she was like baking the eggs and she was cooking and she had her hands dirty. She was able to, while baking with like her right hand, think of the left hand pinch movement and have the iPad scroll. And this demo is 100% real. We refuse to do anything and show the technology until we have something to prove, because part of our ethos is that we are only working on things we believe in, and those things that we believe in, we need to be able to show and prove before we start selling a dream, some sort.
Of course.
And the really human part of what we're doing is that this technology is very early, and as you can see, like it's going to crash during conferences, and these things are going to happen. But we're very excited about what's coming next.
So it sounds a little bit like Black Mirror, you know.
Yeah. You know what's scary about
You're all in black as well, so is it coincidence?
I mean, I like black.
Okay. A few other things that actually came up as well. So when you say you need to think about pinch, do you have to think about that movement, or can you also think about I want to read more or I want to scroll down. Like, or you have to really imagine that movement, that like physical movement of your fingers.
We imagine these movements that we already know. Like if you think about scrolling, that's like an abstract concept, but it's really ultimately mapped to like a gesture or a movement. If when you think, because I wouldn't know necessarily how you think about scrolling, right? How you in your brain think about scrolling. So if your thought about scrolling involves like a motor-based type of movement, it will be detected, all based on that motor imagery concept.
Okay. We also see in many ways, like many technologies that came up, Google Glasses being one of them. Very often form factor makes a big deal. So people just don't want to put around random devices on their heads so that device can read their mind, for example, or to in the Google Glasses case, it's just kind of an obstacle in a way, because you end up putting something on your head, and so this is becoming a part of you as well. So with this particular form factor, is it has to be there, or can it be also minimized somehow? Or do you need to get impulses from all the parts, from those parts of the brain?
We talk a lot about that, like will people wear this? And ultimately, when I think about this, to answer your question, the sensors are designed to be in the positions of the part of the brain that do certain things that we're interested in as far as our applications are concerned. So as you can see, the sensors like right here are all like the motor cortex, and that's the part. We're not even using that much like some of the other sensors that would give better access to like the emotion side and the awareness. But you bring Google Glass, this is an excellent point. And I see people on the subway wearing these huge beads, right?
Yeah.
And they're even bigger. Like our technology has made headphones so small, but they're wearing the very big ones. And I think what it ultimately comes down, this is what I really believe in, is that if it delivers enough value, people will put them on. I think there are major reasons why some of these devices are not being worn right now. One of them is that they require a computer next to them to do all the machine learning and all the processing, which is not the case with this one. This being an autonomous device, you can definitely see how you wouldn't have to have like a computer next to you if you want to use it. And talk to the different devices around you. We did a demo last week in New York where we had one of our friends turn off a light bulb, like a wireless light bulb, with the same type of like imagined thought. So I think if we deliver enough value, people will wear them.
Okay. We have a couple of questions from the audience here as well. One of them is from Maxim. Aren't you afraid that Terminator comes from the future and will kill you and your company right now?
No.
Okay. Okay.
If I'm being honest.
Yeah. Say is asking, was there any research done about mental impact of this technology? Could it provoke some disorders like obsessive compulsive disorder, for example? It's an edge case, of course, but still wondering about any studies in this area.
We haven't seen any research with evidence that can do compulsive disorders. We know that at the basic brain-computer interface level, there are certain areas of the brain that you don't want to train past a certain frequency or within certain frequency, which is not the case with what we're doing. So we actually talked to a doctor that has been doing QEEG, quantitative electroencephalogram, for over 20 years. And we got his opinion, and we felt really good that we were not training the areas of the brain that can potentially promote certain side effects.
Disease.
Ultimately, it comes down that the motor cortex, reading data from the motor cortex and being able to harness that, like motor-based intentions, is pretty safe.
Okay. How many different actions can your device detect at the same time, and how precise can be the action?
We design it so we can do multiple, like different commands, like a handful. As of right now, the state we're in, we're only testing one and making sure that one works really well before we start doing like the combination of multiple. As far as the accuracy, we're working to get past like 60 something, 75% accuracy out of the box at its optimal setting. Turns out that big part of getting great data is all in the mechanical engineering of the device. So the device was designed so it could adjust to different head sizes and touch the exact points that we are targeting, therefore delivering good data, and that's what we are relying on. So a lot of work on the actual like physical side of the product as well as the software. Yeah.
Of course. Yeah, questions like, so when can I start coding by thinking?
I think we're already coding by thinking. We just use our hands. But if you want to use just your thoughts, I see in the near future chipping away at the many repetitive interactions. Like realistically speaking, I want to say right away, it's not realistic. But imagine you could start scrolling, down the code, navigating sometimes the different lines up and down.
Maybe jumping to a particular debug issue we want to debug.
Doing mission control, so you switch from your terminal to their IDE to the browser, and like those very specific type of tasks, we can start automating and hopefully start like chipping away a good percentage of those very repetitive tasks. And as far as the future is concerned, maybe a few years, several years down the line, we can get to a higher percentage of chipping away those interactions. As far as like actually coding, language is a very difficult concept that as of right now, there's not enough research that we can use this more effectively than our hands. And that's the problem. There are BCI protocols, brain computer interface protocols, that you can navigate and spell things out. They're just not faster than us typing them. So why do it?
Yeah, it's interesting that you're mentioning that, because actually when you think about it, so people speaking different languages, would they produce different brain waves to do the same interaction? So if somebody is speaking Arabic and then somebody is speaking English, would it be universal, or would you need to adjust the device somehow?
Simple answer is I don't know, but I know a little bit that language is processed at the same place in the brain. And the specific example that you mentioned with Arabic, I believe Arabic is a right-to-left language. So I actually have no idea.
That was also a very specific question, but I meant like more general, if you have very different languages.
We think that if we could reverse engineer the brain so we could read from like the language part and be able to communicate seamlessly with like a known language, that would be amazing. But as of right now, that has proven to be extremely difficult. So when is that going to happen? I don't know.
Maybe the last one, because Dmitry is concerned about privacy.
Privacy.
Can those brain waves data somehow be intercepted and maybe were manipulated somehow?
So this is the thing. We designed this device from scratch. And before we did anything, we had the conversation, because this is extremely sensitive data that we're talking about. And we're definitely mindful about that. So our approach is one that has not been done before, which is this is the only device that can run the machine learning on the device, right? By doing that, the raw data, the data that could be potentially be used for other things in the future when we know more about that data, it doesn't leave the headset, right?
Unless you lose the headset.
Say again?
Unless you lose the headset somewhere.
No, we don't save it on the device. It's transient. So as we're piping through the machine learning, we're getting metadata that could be the intent, right?
Yep.
So if someone wants to see how many times you have done the left-hand pinch, I mean, good luck with that, but ultimately, we're not sending raw data, and this is something that is a very, very important principle. And we're very happy that we designed this from scratch, because otherwise we wouldn't have been able to do it. So we think the user first, right? That's part of our ethos, and we would never create technology that could put people in a very sensitive place. Like I would never want to wake up one morning and reading the news that because some insurance company got a hold on some users' raw data, they're trying to up their premium and charging them more. Like, this is not why I'm doing work. So I would never leave that to the slightest chance for that to happen. And we're very happy that that approach, that we're not sending that raw data, is the base of having a really good secure device. Similar to the iPhone, right? The fingerprint or the face detection, it doesn't go to the cloud ever, right?
Well, we hope so.
Well, I mean, that's what they're telling us, so.
So it's like,
Yeah.
But maybe this is the beginning of the future we're looking at here. So with this in mind, good luck.
Thank you.
And let's see where it heads. Thank you so much for being with us, Alex.
Appreciate it.
Well done. Well answered.
Yeah.